All right, for today we're going to continue the same concept that we did yesterday. So for your notes, you're actually just going to refer back to the day 1 notes chart. All right, so if you look at problem number 1, now we're dealing with some negative exponents. Problem number 2 has a 0 exponent, and problem number 3 also has a negative exponent. All right, so let's start with the easiest one, which is going to be number 2. So we talked about this yesterday. Anything to the 0 power equals 1. Well, you could distribute the 0 to everything inside the set of parentheses, and then do 2 to the 0, a to the 4th to the 0, b to the 3rd to the 0, and so on. But everything is being raised to 0, so this whole answer is just going to end up being 1 anyway. So don't bother distributing it to everything. Just know that anything, like that big group raised to the 0, should be 1. All right, anything with a negative exponent, that follows the negative exponent rule. So if it's in the numerator, you move it to the denominator. However, we didn't talk about this yesterday, but if you have something, let's say that we had originally been given 5 over x to the negative second, we can take that x to the negative second and we can move it up to the top. So this would become 5x to the second, and nothing's in the denominator because this whole quantity moves up to the numerator. The only change is that the 2 is now positive. So look at where you have a negative exponent. I have a negative exponent here, and I have one here. So in this problem, it's in the denominator. I need to move to the numerator. Well, there already is an a squared in the numerator, so I'm just going to put a to the negative 3rd up next to it. Now remember, when I move it, it becomes a positive exponent. So now, that's my answer. However, it can be simplified. So figure out which rule we're using, and we're using this one. If you have the same base, you're going to just add your exponents. So same base, keep the base the same. 2 plus 3 gives me a to the 5th. All right, number 3, same thing. So this whole thing, a to the negative 3rd, becomes 1 times a to the positive 3rd. Well, 1 times anything is just a to the 3rd. All right, so flip over to the other side. We have a lot of negative exponents. I think it would help if you maybe circle or underline or put a box around the things that have negative exponents. All right, so c to the negative 4th, that's negative, but the 4, that is not negative. In this problem, we only have 2 things with negative exponents, x to the negative 1 and y to the negative 6. In problem 6, x to the negative 4th and y to the negative 3rd. But everything else is a positive exponent or doesn't have any exponent, and in that case it has an exponent of 1. So the only thing you move is the negative exponent, meaning if I've got a fraction, right, this is a 4, that 4 is in the numerator, and this needs to move down into the denominator. So this is c to the 4th, and the only thing that changed is that it's c to the positive 4th. Now 4 is a number, c is a variable, so you can't do anything to simplify or reduce, so that's it. All right, in problem number 5, this one might be even easier to illustrate because there's more things, but anything with a positive exponent or just a coefficient is going to stay exactly where it is. 2x to the 3rd stays, 4 and y to the 3rd stay. The only thing that changes, the y to the negative 6 moves down and the x to the negative 1st moves up. So I'm going to put the x to the negative 1st. Doesn't matter where you put it. I'm just going to write it over here. But it does change to a positive x to the 1st. This one, it was y to the negative 6, so now it's a positive y to the 6th. Or y to the positive 6, really. All right, so now you have to do a little bit of simplifying. So 2/4, we can reduce that. 2/4 is 1/2. All right, if you don't believe me, just divide 2 divided by 4 and change to a fraction, and we have that is equal to 1/2. All right, now you look at, can I combine any, we'll use a different color, like terms? Well, I have x's, those have the same base, and I have y's with the same base. So now we're going to refer back to what is my rule. Well, if I am multiplying and I have the same base, x to the 3rd times x to the 1st, that's multiplication. So I add my exponents. Keep the x the same. 3 plus 1 is 4. Here, I'm doing the same thing with the y's. 6 plus 3 is 9. All right, so I have 1x to the 4th over 2y to the 9th, and you can leave that as your answer. You don't really need the 1 there, but if you want to keep it, you can. And these don't reduce because x and y have different bases, so those are considered not like terms. All right, so in number 6, the 1 stays there, the 6 stays there, the z to the 5th stays on the bottom, but these two quantities move up to the top. So x to the 4th is now on the top, and y to the 3rd is now on the top. All right, so now look, can you reduce 1 6? No. Can you add or combine x, y, and z? No, because they're all different, so this would be your final answer. You can leave off the 1. That might be the only thing to really change, but otherwise, there's your result. All right, number 7. So where do you have negative exponents? The only negative exponent in number 7 is a to the negative 2nd. This negative 10 is not a negative exponent. It's a negative coefficient. So I'm going to keep the negative 10 there. There's nothing that says you can't have a negative 10 in your numerator. The 2 stays, the a squared, the b cubed stays. The only thing that needs to move is my a to the negative 2nd. So I'm going to move that down here. Okay, so I have all positive exponents. So now at this point, once you have all positive exponents, you just use your product rule. Okay, look for things with the same base. Well, a squared and a squared. How many total a's do I have? 2 plus 2 is 4. I can also reduce negative 10 divided by 2. That's negative 5. A to the 4th, we decided that was, and that's in the denominator, so keep that in the denominator. And then I'm just going to recopy the b cubed and the b here. So we haven't done anything yet, but we can. All right, so now we've got the quotient rule. We haven't used this one yet, I don't think. And we're dividing. They have the same base. They're both b's. Now, what are your exponents? You have a 3 and a 1. So when you use the quotient rule, I would take the larger of the two, right? 3 is larger than 1, and just subtract 3 minus 1. So we keep our negative 5. We keep our a to the 4th. 3 minus 1 is 2. And where did you have a larger exponent? That was on top. So we're going to put the b squared on the top. If we have a larger number on the bottom, then we would put the result on the bottom. All right, number 8. So I've got a negative 2 on the outside. That needs to be distributed to everything. So we have a to the 4 times negative 2, b to the 3 times negative 2, over a, this is a 1, right? 1 times negative 2, and b to the 3 times negative 2. So that is your power to a power. Keep the same base, multiply your exponents. All right, so a to the negative 8th, b to the negative 6th, a to the negative 2nd, and b to the negative 6th. All right, but now I have a lot of negative exponents. So anything with a negative exponent needs to switch to the other part of the fraction. Well, now that means everything is switching. So this goes down, this goes down, this goes up. Okay, so now instead of in the numerator, instead of these being there, I have a squared b to the 6th. These two things just moved up. And then these two move to the bottom, a to the 8th and b to the 6th. All right, so now I'm going to use my quotient rule again. In my quotient rule, I look for the same base. So if my bases are the same, you just subtract your exponents. So I don't want to do 2 minus 8. I want to do 8 minus 2. 8 minus 2 is 6. So where did I have the bigger amount of exponents? It was in the bottom. So I'm going to put a to the 6th on the bottom. And then here, 6 minus 6 is 0. So now I've got b to the 0. Well, b to the 0 is 1. Or in other words, if I have 6 minus 6 and I get 0, that just cancels out. So this would be my answer, but you can't really leave a fraction with just something in the denominator. So you just put a 1 there. So you have 1 over a to the 6th. All right, in the end, make sure all your terms that are left over, they have not like bases, and there should be no negative exponents. Just make sure they're all positive exponents. All right, last problem. So I see a 0 power, and we said anything to the 0 power is equal to 1. Okay, but that doesn't mean the whole entire problem is equal to 1. Just this part. This is the only thing that's being raised to the 0 power. So this is equal to 1. For this side, I need to square everything, which includes doing 4 squared, x to the 3 times 2, and y to the 2 times 2. Okay, so how much is 4 squared? That's 16. I don't really have to bring down the 1 because 1 times anything is just itself. And then x to the 6th and y to the 4th. All right, and x and y are different bases. I don't have any negative exponents, and everything is simplified as much as possible.